My name is Melanie Griffith and my partner is Caylie Charlton. And for this presentation, we will be discussing locating a target chip using digital controls. So some background to this issue is due to the rise in popularity of cryptocurrency and NFTs, it is becoming increasingly important to discover and understand the vulnerabilities that hardware wallets have. Hardware wallets based on the STM32F3 architecture are already known to be susceptible to electromagnetic fault injection attacks, which is abbreviated EMFI. In order to perform an EMFI attack, you must first line up an injection probe with the chip, and it needs to be touching the chip. This project will aim to locate and align the injection probe to a target board on the XYZ bed and efficiently and safely.
So our problem statement, the problem statement for this project is to figure out how to locate and align an EMFI probe to target board using an XYZ bed. Currently, the controls for the XYZ bed are manual and not super user-friendly, so the target board can also be damaged with the current system due to the lack of depth control. Our goal is to create a simpler and more accessible control system by finding and lining up the EMFI probe to create a simpler and more accessible control system to help with finding and lining up the EMFI probe and to make that system a little bit more efficient. And so Melanie Griffith will be working to accomplish that goal. And so the second part of our problem statement is that EMFI attacks can be super dangerous and negatively impact other electrical devices, going as far as to impact pacemakers and other electrical medical equipment. So I'll be working on adding a wireless aspect to help the researchers keep a safe distance from the setup and make it easier to input the coordinates to move the XYZ bed.
So the current setup is the three pictures that are shown here. The picture on the left shows the XYZ bed as a whole with the target board attached to it. And as you can see, the little gold tip is the injection probe, and it needs to be lined up to the little black square dot on the target board. As you can see, it's really hard to line up with your eyes and the manual controls. The top picture is the chip whisperer, which analyzes the glitching that the EMFI attack causes on the target chip. And the bottom picture is the CNC router, which moves in the Y direction up and down. And that's very important because you can run through the target board actually if you're not careful with the current system, which is also a fault that we would aim to fix.
So in order to create the set of digital controls, we will have the following steps be completed. So we'll start with initiating the connection between the Raspberry Pi user interface and the chip whisperer. We'll get user input from the X and Y dimensions. We will send that user data to the X, Y, and Z bed and check to see if the dimensions will cause harm to the board. So that is if it is either out of bounds in the X and Y dimensions, or if the Z dimension will damage the chip. If so, we'll ask the researcher for new coordinates. Then we will execute a movement sequence. We will verify the target board has been found, and then we will initiate the connection between the Raspberry Pi and a Pi whisperer, and that will trigger the EMFI attack using the chip shouter.
So for our completed and future work, we're following the engineering design process, and we are currently on the steps of gathering information and data and brainstorming solutions. So the tasks that we have completed so far include finding an advisor for this project, developing an end goal for this project, creating divisibility between task members with the help of said advisor, and assessing the current setup. The tasks that we have yet to complete are selecting a microprocessor to interface with the XYZ bed, and we're currently leaning towards the Raspberry Pi. Researching needed hardware materials, including a camera, control platform, distance sensors, motors, and so on. Manufacture a substitute EMFI component for testing, which is the Z-axis, and we want to 3D print a design for a laser pointer, which would substitute the EMFI probe, and design a testing validation process. And